Hello everyone, I'm going to talk about dynamic node programming feature for the Xen hypervisor. Uh, Before we jump into what we can accomplish with the dynamic programming, I just wanted to talk about motivation behind it, like how we got the idea. So dynamic programming is basically used for FPGA since long time. Uh, FPGAs are basically semiconductor devices which can be reprogrammed to different applications even after manufacturing. And FPGA always has this flexibility to reprogram the region of the device during runtime. And this reconfiguration involve like we can reprogram basically, we can reconfigure CPUs or BRAMs, DSPs, and high-speed IOs and stuff. Now, this reconfiguration or reprogramming has its own benefit. It basically allows us to make more efficient use of hardware resource. We can keep the system running while we are making the other changes to separate part of hardware. And of course, it helps like reducing the power consumption. Few of these use are in data centers like Xilinx provide an LVO card, which is used in Azure Cloud for FPGA as a service. What this does is that we can reconfigure different parts of the card to support like different applications like machine learning, inference, video transcoding, uh, database search, and analytics. Second application is automotive, which I'm going to talk in the next slide. And the third is wired and wireless application, where basically network switch application can expand their capabilities by loading different traffic protocols on the demand. Uh, let's take a little bit more about the automotive case. So for the automotive case, what we can do is that when we have a SoC, we can use the uh, FPGA part of the SoC for like before we start the car, so we can use the SoC functionalities to take care of like functions like keyless entry and monitoring the vehicle and biometric identification. And once the vehicle is start and it's like exiting the parking lot and stuff, we can basically enable 360-degree views, surround camera, and other stuff. And once the vehicle reaches at a good speed, the same hardware can be used for a different like the lane departure warning and other like proximity detection for lidars and stuff. So the same component of hardware basically can support different applications. We don't need to because these are like mutually exclusive. We need to keep all of them running at the same time. We can just utilize the hardware as we need it. So how we do it, if we remove Xen from the picture, like how it's done in normal Linux boot. So it happens in two stages. And the first is that it loads the bit stream to the FPGA region. And second, it notifies the Linux kernel that, okay, there's a new device or there's a new part of the hardware which is available. And for removing, it's going to be pretty much similar. We again tell the FPGA region, or we just send the FPGA region to mark the region as gray box, which means there's no functionality. And we remove the device tree overlay from Linux tree. So the first step that is about like programming the FPGA, which is like bit stream loading. So how it happens is that the user level applications basically sends a bit stream that it want to program, and it goes to Linux. From Linux, it goes to ATF, and from ATF, given that it's a heterogeneous platform, so there is an FPGA and there is an basically ARM. So For FPGA part, it basically goes to IPI, and that goes to the FPGA region. Now, this is a blocking call, which means the user application basically waits for response from the driver basically waits a response from ATF, and once it's done, it's going to do the next work. So the next part is that now the FPGA's program, we just like add overlay in the Linux tree, and we can probe the driver. Now, because the Xen environment has multiple VMs running at a time, and VMs can basically provide different functionalities for the system, we can utilize this dynamic programming features in the Xen hypervisor. But right now, the problem that Xen has that they don't have support for overlays at all, and it can allow the uh, FPGA utility to basically program the FPGA hardware, but uh, there's no existing way for us to update the Xen device tree, and there's no existing way for us to like inform the Xen hypervisor that there's a new node available. So, and also the FTT version, which was existing, was 1.40, which did not have support for overlay nodes. And last part is that, again, this same thing. What if we change the functionalities of hardware? How do we tell the hypervisor that, okay, there are some nodes which are going away? So for as I talked in the last slide, for the bitstream loading part, it's pretty much similar, even though Xen is there because it's not going to block anything. The bitstream will go to FPGA, and FPGA region will get programmed. But when it comes to like Linux, basically probing the driver or bring up the driver related function, it's going to be a problem because the request needs to go through Xen EMI calls. And given that the Xen doesn't have the overlay information, this won't go through. So that's the thing that we are missing in the Xen hypervisor. So what we did, what are the changes that we made in Xen hypervisor to make it work? First, that in the device tree compiler, actually it's not part of Xen, it's a separate rep only. So the device tree compiler maintains the libftt, and there were like small changes in the FTT overlay. Those are already in the upstream branch. For the Xen, we updated libftt to 1.6.1. Actually, that patch is also in the Xen tree. Then we added new hypercall, and we added basically functionalities for how to parse the overlay and how to update the Xen device tree. And once we have the information about the new nodes, and we added the device tree, we updated the device tree. Sorry. So how we can like map the MMI and interrupt to the required node. For the Xen tools, again, to support this, we basically updated the Excel tool with the extra command name overlay. And for libxl, there's one more feature that we have added for DOM-U, because if you remember, DOM-U's Linux tree has a different p-handle IDs and stuff. Like if you talk about interrupt parent, those are not like standard interrupt parent IDs. They start with FT something address. So we have added some changes in libxl to basically auto-generate the device tree overlay, which is compatible for DOM-U. So how it works, for DOM0, let's say you want to assign a new node to the DOM0, which is running. What we do is that we just do Excel overlay add and the overlay name, and this is the ID of DOM0. So the call goes from Excel to libxl to libxc, and then it makes an hypercall with the device tree overlay and which domain it want to assign and the overlay type, add or remove. For add, what we do is that we basically unflatten the overlay and we add that to DT host, because as we know the Xen has DT underscore host device tree, which is which basically used for all the mapping and stuff, and that's flattened. Sorry. And then the next part is that once we have added the node in DT underscore host, we need to map the IRQs to DOM0, and we need to map MIOs to DOM0. And the last part is that we are also keeping the track of all the nodes that we have added. So when we remove the nodes, we can also free the memories. For removing part, it's so right now the only constraint that we have put that we basically allow only the nodes which were added by the user. We do not allow like any random node to be removed. So we every time the remove request come, we check whether the node, of course, the node needs to be there, and does the node also exist in the system that we use to track the new nodes. Second is that whether the node is being used by any domain or not, and then if it's not being used by any domain, we just remove the IRX and we remove MIU mappings, and finally we remove the node entries from DT underscore host. Let me show you a quick like demo about how to use this for like DOM0. So in the demo,
So you're the presenter. Do you want to do it? Or you want me to do it?
yeah,
So you're the presenter.
okay,
Okay. So I'll make myself presenter, and then I will copy this link here, and I will share an external video.
okay. So in the demo, what we are doing is we are just adding a Ethernet node. We are adding the Ethernet node in the Xen tree, which doesn't exist right now. So there is no IP addresses and stuff. So what we did was that we added the overlay node and assigned to DOM0, and then we did the mod pro for DOM0 Linux, and we can see that the Ethernet driver is up, and we were able to basically do the test for downloading the file. So, oops. Okay, I think we can move to the next slide. Okay. So we saw that how it works for DOM0, and we earlier talked about like for DOM-U, we will need little bit modification in the device tree overlays to make it compatible for DOM-U. So for DOM-U, we basically provide two modes. One of the mode is like expert mode, where we rely on the user that they will make the DTPO appropriate for DOM-U guests. And so for the expert mode, it's going to work exactly the same as DOM0 case. We just do Excel overlay, add, and the name of DTPO and ID of the ID of the DOM-U. For normal mode, it's going to be a bit different. So I'm going to talk about that in the slide after this. Okay, so expert node, as we talked earlier, for DOM-U is going to be work pretty much same as DOM0. So it's exactly the same flow for the add. We are just going to add the tree, add the node in the tree, and map the IRQs and MMIOs, and for removing, we are going to do the same. For normal mode, because we are modifying the overlay in the libxl and we want to share it with DOM-U, so we basically implemented a small protocol using XenStore to basically share the device tree overlay between DOM0 and DOM-U. So what happens is that once when the Excel like when the part on the left side starts, everything else goes same as the like DOM 0 modes and DOM U expert mode. Just the libxl has extra step, and what it does is that it waits for a get overlay application to start from DOM U, and what that application does is that it creates a few entries in XenStore to exchange the data. And so get overlay first like writes for by sender we mean libxl, and by receiver we mean get overlay part. So what it does is that it's write initial status to these, and once libxl gets the uh, uh, receiver status as ready, so what it does that it has information about the overlay, so it copies the size of the overlay here, and once the DOMU get overlay knows how many bytes the overlay is going to be, it allocate the pages and it shares the page reference. And once libxl gets the page reference, it's basically copies the overlay to that page and it marks as done, and then DOMU basically copies and unshare the pages. The last bottom three are pretty much applicable for FPGAs. Like FPGAs has overlay type, whether like you want to configure the hardware partially or you want to configure the hardware full. So for that, these options are basically being provided. So once the get overlay basically copies the file, we also provided a get overlay.sh script, which is a bash script, which can also take input about like what is the name of the node that you want to, and what is the name of driver that you want to basically probe once this node gets in the tree. Okay, can we also play this?
Sure, Vikram, we lost connection and dropped off, like, and basically couldn't hear your last slide. Would you mind going to the previous slide and just
Sure,
going through it again? Is that all right?
sure. Yeah,
30 people that, that didn't hear anything about the slide. Thank you.
no worries. Yeah. So in the DOM view normal mode, lessons like almost everything works like same as it works for like DOM-U expert mode or DOM0 mode. libxl has like one extra small step which it used to share the modified overlay with DOM-U. So what happens is that libxl basically waits for get overlay application in DOM-U to create a few entries in XenStore. So it creates these 8 entries in the XenStore, and it tries as the receiver status is ready, and so in this case the receiver is going to be DOM-U and sender is going to be libxl in DOM0. So what happens next is that libxl basically has information about the overlay, so it writes the size of the overlay here. Once the get overlay function knows the size of overlay, it allocates the page and writes the page reference. Once libxl knows the page reference, it copies that overlay to that particular page, and it marks it as done. And once get overlay knows the status is done, it copies the overlay and shares those pages. Other thing I was like talking about these 3 entries in the bottom, these are like pretty much specific to FPGAs, because FPGAs support like partial reconfiguration or full reconfiguration. So that's just like information about those. We also added a get overlay.sh script, which what this script does is that it can also take arguments like which drivers you want to probe and what is the name you want to assign to the overlay and stuff. So it can also like automatically probe the driver and get the system up. So Next one, this is like a demo. Basically, it's a next part of the previous demo. In the previous, if you remember, we assigned a node to DOM0. So now we are going to take away the node from DOM0, and we are going to assign the same node to DOM-U now. So we have two domains here. One is so guess 0 is to domain 3. And the node was basically assigned to DOM0, so we are going to remove it from DOM0 and then add it to DOM3. So here we have Ethernet underscore Linux underscore DOM-U.dtbo file, which is basically modified for DOM-U. And once we assign the resources to DOM-U, it's able to prop the driver, and it's also able to see the internet or like Ethernet driver. Okay. I think we can go to the next slide. I don't have control to move to the next slide. Hello. Okay. So I'm assuming that everyone can hear me now.
Yeah, we're back. So go ahead.
Awesome. So yeah, in short, I just like wanted to show the commands that we use for DOM0 DOM-U mode. So we just like, this is pretty simple. For DOM-U, we like, this part is like same as the previous. It's just we add the overlay node name and type of the overlays, and from DOM-U we just like start this script which basically takes care of the data transfer between DOM0 and DOM-U. And for remove, it's pretty much still here, it's same, and we just add the name of the overlays and type and stuff that we did earlier. So this is how we can use it for both the DOM0 and DOM-U's. We already sent, I think, V3 patch, and we are going to send V4 now to the upstream, and probably it should be in the tree very soon. Yeah, that's all I have.
Okay, are there any questions? No? Well, let's thank our speaker.